Today we have a theory of seafloor spreading. As you can see from the lesson objective, the lesson progresses right down to assignment. We have a brief overview of the theory of seafloor spreading. We believe that the students already have gathered idea about the theory of continental drift that was postulated by Alfred Wegener, who published the principle in 1915 titled The Origin of Continent and Ocean. Seafloor spreading refers to the movement of the ocean floor from mid-ocean ridge towards the continent. This theory was postulated in 1960 by Harry Harlan Hess. According to the Hess's principle, the ocean floor is gradually moving towards the continent. And Harry Hess made us to understand that the ocean floor is made up of diverse features like mid-ocean ridges, sea mouth, sea plateau, abyssal plain, and so on and so forth. How did he discover that? Harry Hess built up a team that used a ship called the Glomar Challenger. They determined the ocean floor. The depth of the ocean floor was determined using the sonar sound, where a sound leaves the ship, hit at the ocean floor, and takes time to return. So the time taken by the sound was used to calculate the depth of the ocean. And after that, we realized that after moving throughout, exploring almost all the different parts of the ocean, the depths were very, very unique, which means that there were certain obstacles to the sound, to the sonar sound. And so Harry Hess decided to explore the ocean floor, and he discovered that there are so many features that are found beneath the sea level. So he postulated his theory known as the theory of seafloor spreading in 1960. Harry Hess was a geophysicist. He studied geology and did physics, and he recruited a team of marine geographers to carry out his research. So, according to Harry Hess, if you look at this diagram, you will see that you have a magma chamber here, then you have the ocean. So when new materials come upward, cool and solidifies, the older ones are pushed away. The movement of the older material towards the continent carry rocks of different ages. And so at subduction zone, when these materials meet the continent, the oceanic materials are much more denser, heavier than the continent. And so it moves down. The process whereby the oceanic material bend and move down towards the mantle is called subduction. So it is at subduction zone that deep valleys called deep sea trenches are created. Harry Hess tabled a handful of evidence to convince the world that the continents were moving, one of which was the ages of the rock. How did he convince the audience about that? So he used the ages of rock. He said that when new rocks are created here, the rocks are very, very young. And so with time, as the solidification takes place, these rocks that were formerly formed are now pushed towards the continent. And so you will always have very young rock, recent rock at the mid-ocean ridge, and old rock toward the continent because they are being pushed away. The second evidence that Harry Hess put forth was magnetic polarity or paleomagnetism. According to Harry Hess, during formation of rocks, rocks have minerals. The minerals could be iron, it could be aluminum, it could be silica, it could be quartzite, and so on and so forth. But during formation, the rocks are laid down in layers. The alignment of the rocks take the magnetic polarity at that particular time, because from geologic time scale, the Earth's magnetic polarity keeps moving to different directions. Well, it is very dichotomous. The dichotomy of the polarity is north and south. So during formation, if the rocks are formed where the magnetic polarity are pointing towards the south, it means that both the rocks from the different side of the mid-ocean ring are going to take that very polarity. That is why from this diagram you will see that you have rocks from after the mid-ocean ridge here. You see that the rocks here have a south polarity from both sides. As you move towards